Okay, so this is our notes for Geometry, Chapter 8, Lesson 2. This is going to be on something you're probably a little familiar with, the Pythagorean Theorem. And really, you know what the Pythagorean Theorem is. Really, it's a relationship between lengths of sides for a right triangle. Okay, so got to have this right triangle, and we know we have leg A, leg B, and we have C, which is the hypotenuse. And we can just put this into an equation: a squared plus b squared equals c squared. So if we take squared, we square A, we square B, we add them together, it will be equal to what C is squared. Okay. There's also something, though, that we're going to start using with triangles. It's something called the Pythagorean triple. And these are a set of numbers or lengths of sides that will allow us to determine whether something is a right triangle or not if it has these three sides and they match up. Okay, and the thing we have to remember, though, for this, it cannot be 0. None of these sides can be 0, which kind of makes sense, right? If one of the sides is 0, you really just don't have a triangle anymore. Plus, we also want whole numbers, so we don't want halves or anything. If that's true, so these sets of numbers, they can't be 0, and they have to be whole numbers. And these sets down here, they fulfill the Pythagorean theorem. So they tell us if we add the two legs together, then we will get a squared plus b squared equals c squared. And really there's 4 of them. There's 3, 4, 5 triangle. There's a 5, 12, 13 triangle, 8, 15, 17 triangle, and 7, 24, 25. So this is like A, B, C, right? A, B, C, A, B, C, and A, B, C. C is always going to be the longest side, right? And if we did this, we'd figure out that, 3 squared 9 plus 4 squared 16, 25 is equal to 5 squared 25. 25 equals 25. But we can also, if we know these 4 basic ones, we can then also do multiples of them. So if we take every one of these numbers and multiply them by 2, and we get 6, 8, 10, that's also another triple, Pythagorean triple. We take all these numbers and multiply them by 3, 9, 12, and 15. These are also another triple, and so on. So really, if we just take 3, 4, 5, and we multiply them by the same number, we will still get that triple. The same with these, 5 times 2 is 10. Do all these by 2, we still get that same triple, and so on. You can kind of see this if you want to write these down in your notebook. Really, the only thing you need is the 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25. And just know that if you multiply any of these numbers, them all by the same number, then they will fulfill this idea of the Pythagorean triple. Okay, let's keep going. So another way to look at the Pythagorean theorem is like the opposite way, the converse of it. And this one really says, really not that different than the Pythagorean theorem. It says if the sides, the leg, hypotenuse, fulfill the Pythagorean theorem, then the triangle is a right triangle. Okay, so if we take leg A and we square it, and we add leg B and square it, and we add those together, they will be equal to the hypotenuse of the longest side. Okay, so if we don't quite know if a triangle is a right triangle, we can find the longest side, assume that's the hypotenuse. The other two sides, we square them and add them together, and we square that longest side, they should be equal to each other. That's another way of looking at the Pythagorean theorem, and it can help us figure out if the triangle is a right triangle or not. Okay, so that's the converse of the Pythagorean theorem. And then we also have this last one here. This is the Pythagorean inequality theorem. Okay, this says if the square of the length of the longest side is less than the sum of the lengths squared, legs, then the triangle is acute. Okay, so that means if we have a triangle and we square the hypotenuse and it's less than the sum of the lengths of those sides squared, then the triangle is an acute triangle. Okay, and then also if we square the longest length, okay, and it's greater than the sum of the lengths of the legs, then the triangle is obtuse. And the thing you want to remember about this one is this is not a right triangle. Not a right triangle. Okay, well we can figure out what the longest side is. We can square it, and then we square the other legs, the two other sides, and if the longest side is less than, then we know it's an acute triangle. But if we go the other way, if they're if the longest length is longer than the squares of those other legs, then we know the triangle is obtuse. Okay, it wouldn't be a right triangle, but the longest there. Okay, and that's kind of our notes on Pythagorean theorem. They're pretty short. Add them to your notebook, and we'll do some application of this in class. And let me know if you have any questions. Just make sure you keep adding these to your notebook, and talk to you in class.